next topic is eddy currents. What is the meaning of eddy current? The circulating currents are produced in a conductor due to change in magnetic flux is called eddy currents. The circulating currents are produced in a conductor due to change in magnetic flux linked with the conductor is called eddy currents. Once you see the diagram, now you can understand the things very easily. See, here I am taking a strong magnetic field. This is north and this is south. Now here I am hanging a big metal plate between north and south of strong magnetic field. Now see, imagine if it is the metallic plate, if that metal plate is oscillating between north and south of a strong magnetic field. That means simply it is oscillating between strong magnetic field like this. Like this, the plate is oscillating. Now, what's happening? The flux is passing between north and south. Every time, if the metallic plate, if it is oscillating, what is happening? It is cutting the magnetic flux. Then in turn, the area is changing. If the area is changing, what is happening? Finally, the change in magnet, because of change in magnetic flux, then the induced currents are produced in the conductor. Here, the induced currents are produced in the conductor. Then, that induced currents direction is we can get by using Lenz law. What is the direction? The induced currents direction is that induced currents are producing magnetic field which is try to oppose the applied magnetic field. And finally, because of this currents, what's happening? Finally, because of this currents, magnetic field is produced. This magnetic field is opposite the applied magnetic field, and finally, what's happening? The body oscillation is slowly decreasing, and finally, it comes to rest. So, such type of currents we call it as a eddy currents, and this was discovered by Foucault, and it is also called as Foucault currents. So, once again, all of you try to understand the meaning of eddy currents. These are the circulating currents which are produced in the conductor due to changing magnetic flux. Changing magnetic flux linked with the conductor. When a conductor, a metallic plate is placed between a strong magnetic field, if it is oscillating, and these are changing the magnetic flux, and because of changing magnetic flux, induced currents are reducing. The circulating and induced currents, we call it as a eddy currents. Eddy currents. What is happening? These induced eddy currents producing magnetic field which try to oppose the applied magnetic field, and finally because of this opposition the body comes to rest after some time. Now how can you decrease this eddy currents effect? In place of the single metallic block, if I am using, if the metallic plate is cut like this, the metallic plate is cut like this, then the eddy currents are minimized. How? Because here if I am cutting like this, sheets like this, the area is minimum. The area is minimum, automatically the flux changing is also minimum, and finally the producing of eddy currents also minimum. Now we see the advantages and disadvantages of eddy currents. See the advantages. It is used in speedometer, induction motor, induction furnace, induction stove, induction stove, galvanometer, next energy meters. In all applications and also braking in electric trains, and energy meters. In all applications, we are using this eddy currents. How? See, in every vehicle, you can see the speedometer. What is the speedometer? What it gives? The speedometer gives the instantaneous speed of the vehicle. How it works? In a speedometer, in the front wheel, I think you will find the like this metallic drum and spokes will be there. And spokes will be there. In the central one axis will be there. There one magnet is attached. That magnet is continuously rotating, and because of continuous rotation and one more substance it is attached to this aluminum drum, then what is happening? The magnet is continuously rotating according to the speed of the vehicle, and because of that one the flux is changing. Because of changing magnetic flux, the eddy currents are produced. By using the eddy currents, we can know the speed of the vehicle. And induction motor, induction furnace. Induction furnace means where the heavy metals can be melted by using eddy currents. The heavy metal which we want to melt, that is kept in a high frequency magnetic field. Then high frequency magnetic fields are varying, magnetic flux is changing, then the magnetic flux is causing eddy currents in the heavy metal. Because of high resistance, it is producing a lot of heat. Because of lot of heat, the metal gets melted. And next, braking, electric braking in trains. In trains, especially the part of wheels, electromagnets are attached. If you want to brake the train, the current is passing. If the current is passing, that creates eddy currents in the wheel. Because of eddy currents opposing, it creates a magnetic field. The magnetic field is trying to oppose the motion of the wheel. In such a way, we can stop the trains. So, like this, a variety of applications. Again, the galvanometer, dead weight galvanometer. Because you see, in a galvanometer, if it is like this, here one needle will be there, it is showing the readings 3, 4, 5, 6 like this, it is showing the reading. If the current is passing, it shows the reading. Once after that one, if it is stop the current, again the galvanometer comes to the stopping position. Why? Because here once the current is stopped, eddy currents are produced because the eddy currents are pulling back the needle to its original position. So in the dead weight galvanometer also we are using eddy currents. So like this, a variety of applications are there for eddy currents in day-to-day life. Once again, you see the speedometer, induction motor, induction furnace, induction stove, galvanometer, electric braking in trains. In all these applications, you will find a lot of applications in day-to-day life. Next, disadvantage. See, these eddy currents are causing a lot of heat. This is unwanted. Because heat is produced, the efficiency of the engines is lost, energy is wasted, efficiency is lost. So this is unwanted effect. So that is the way sometimes it is useful, but some areas it is disadvantage. The disadvantage is mainly it is causing, it is producing heat, and finally energy is lost. Energy is lost in the form of heat. And finally, efficiency is also lost. Then, how can you minimize this eddy currents? See, minimize eddy currents. See, how can you minimize the eddy currents? Especially in transformer, eddy currents are formed. Because of this eddy currents, a lot of heat is generated, and that is the reason the transformer lost the efficiency and finally it loses its lifetime. Then how can you minimize these eddy currents? See, suppose if it is the core of the transformer, if it is a single block, if you take the single block, then here eddy currents are produced. Because of this eddy currents, heat is generated and finally energy is lost. But in place of single block, if I am using number of parts, number of blocks which are placed one by one. This is one part, this is another part, like this. Like this. Number of parallel plates which are placed. Between the parallel plates, a laminated core is attached, pasted. Here laminated core, here laminated core, here laminated core, here laminated core. Like this. At each and every part, a laminated core is pasted. Then what is happening? In such a condition, if eddy currents cannot interact with the neighboring plate. That is the reason once here eddy currents are formed, that eddy currents cannot pass into the next one. Here net cannot pass to the next one because the insulator is blocking this eddy currents. So reaching from one point to another point, and that is the reason here eddy currents are formed. There only it is blocked because of laminated core, and finally here in this one, the only one or two parts only it can reach, and rest of the parts it cannot go. Finally, in this way, the eddy currents are minimized. Eddy currents are minimized means heating effect is also minimized. So once again, all of you try to understand the eddy currents. See, eddy currents are nothing but circularity currents which is formed in a conductor due to change in magnetic flux linked with the conductor. It is called eddy currents. Who discovered? It is discovered by Foucault. That is also called Foucault currents. Then what is the direction of eddy currents? This direction you can measure by using Lenz's law. What is the direction? In direction, because of eddy currents, it is producing magnetic field. That magnetic field is opposing the applied magnetic field. What are the advantages of eddy currents? Eddy currents are used in induction motor, induction stove, induction furnace, electric braking in trains, speedometer, deadbeat galvanometer, like this, so many applications are there. What are the disadvantages? The main disadvantage is because of eddy currents, a lot of heat is produced. Because of this lot of heat, energy is wasted, and finally the vehicles lost the efficiency. And how can you minimize? Instead of using single block, if you are using laminated cores which are placing parallel to each other, and eddy currents are minimized, and finally the heat is minimized, and finally you can increase the efficiency.